Hey everyone, let's try to solve another LeetCode problem today. In this problem, you are given a string s and an integer k, and a k subsequence is a subsequence of s with the length k, and all of the characters are unique. So another operation is fc. It denotes the number of times of the character c occurs in s. And the beauty of a k subsequence is a sum of fc for every character c inside the k subsequence that we have picked. For example, if we consider s is this string and k is 2, we can see fa is 1 because a only appeared one time, and fb is 3 because it appeared here 3 times, and fd is 2 because it appears at the end for twice. So now, with that in mind, we can pick k subsequence of s where k is equal to, so it means that we have to pick a subsequence of size 2 inside s. So what options can we pick? So for example, we can pick this ab, which is a subsequence of s, and AB is having a beauty of 4 because FA is 1 and then FB is 3, so 1 plus 3 is 4. Or we can take a subsequence of AD where having a beauty of 3 because FA have a subsequence beauty of 1 and FD have a beauty sum of 2, so 1 plus 2 is 3. And or we can pick a subsequence of BD where B has a sum of 3 and then D has a sum of 2, so 3 plus 2 is 5. So let's assume that 5 is the maximum that we can get, but we are not trying to return the maximum. We are trying to return the number of k subsequence that we can reach the maximum. So for example, in here we don't want to return 5. We want to return how many subsequence that we can reach this 5. For example, this BD can be one operation to achieve 5, so this is 1, or this B and then the last D. So in the beginning we choose second last D, and this time we choose the last D. This can be another choice that we can reach 5, or we can choose the second B and then the first D, etc, etc. So we need to return how many subsequence that we can reach 5 instead of returning 5. So let's first think about what is the maximum k that we can get. So from the program description, we know that k subsequence must be all unique. That's why it doesn't make sense for it to be greater or equal to 27 because we only care about lowercase letter from A to Z. If there is a k equals 27, how can we get the answer? So it is not possible to reach anything that is greater or equal to 27. So that's our first observation. K must be less than or equals to 26. And if it is not, then we can just return 0. Next, if we know that we're going to pick 8 of them, then which should we pick? So in the example, you can see that our k subsequence always picks C. So here we didn't pick C, but this is getting 2, but 2 is not the best we can do. So basically we ignore this. So for every valid answer, we always pick C. Why? Because C is having a higher frequency. Remember, we always want to reach the maximum beauty. So it makes sense that we always choose the top k frequency that we can pick. So again, max beauty is equals to top k characters we can pick. By top k, I mean the most frequent k characters, or most frequent k characters. So with that out of the way, let's try to go through the maximum frequent to the lowest frequent. What I mean by that is that we can build a hash map saying something like repeat of frequent. It just means how many times this frequent occur. For example, this 2 only occur once. So 1 will have a key of 2, and then for frequent of 1, then it appeared twice because we have 2 places that we can reach 1. So that's why we basically we have 2 options. So this is like a hash map, and let's think about how this hash map can help us calculating the answer. So again, as I mentioned, we need to go from the most frequent to the least frequent, because the most frequent can bring us more beauty score. So first we are looking at 2, because 2 has a higher frequency. And how many places we can get 2? Well, we only have one place or one character that we can get 2, which is C. And because we have a frequency of 2, so it means that we can have 2 places to choose this beauty score. Basically, we can choose the C from index 1, or we can also choose the C from index 2. That's why we can do 2 times here. So that's how we're going to consider the first character. Remember, after considering the first character, we need to do k minus equals 1 because we already picked it. So k originally is 2 and now it become 1. K is now 1. So the next step that we want to pick is 1 because we don't have any more frequency in here in 2. But if we have like a repeat, let's say 2 or 3, then we will do 2 to the power of 3 or 2 to the power of the repeat time, because for each choice we have 2 indexes that we can pick and we have repeat choice. So repeat is the value in here, but in this case we only have 1. So that's why it's basically 2 to the power of 1. But if, let's say, we have a repeat of 2, then we don't do k minus equal 1, we do k minus equals 2 here. So anyway, but in here we only have a repeat of 1. So we just do this 2 to the power of 1, which is 2. And then we go to the next choice that we can pick, which is to choose a frequent of 1. So to choose a frequent of 1, we have 2 choices to pick. We can either choose D or we can choose A. Normally we will say 1 to the power of 2, right? But notice we don't have enough K to pick all of the 1. So that's why we have to do something special. Notice K is already smaller than the repeat here. It means that we can only choose 1 from these 2. So what I'm trying to say is we need to do something like NCR. Basically is N choose K, the math formula, where N is the repeat time and then K is the remaining K that we need to pick. And inside that K, we can do a key to the power of K. Remember, key is the frequent. So each frequent will repeat K times, and we can N choose K of them. So where N is the repeat. So in here, key is 1 and the remaining K is also 1. So 1 to the power of 1. And NCR 2 and 1 will give us 2. So in total, 2 times 1 to the power of 1. So 1 to the power of 1 is just 1. And 2 times 2 give us 4. So that's how we're going to reach 4. And after that, we will exhausted all the K that we can pick and we just break out the loop. And the total will be 4. 4 is our answer. So that's how we can achieve the answer by using this algorithm. So let's see how can we implement it in code. So first of all, from line 3 all the way to line 35 will be some code for calculating the NCR under the modulo. I don't think in the interview you need to know this. I have to do this because in LeetCode there is some verification. When the integer is too large, then we have to mock the answer to the 10 to the power of 9 plus 7. But in a real interview, we don't have to care about them usually. So, and also this kind of code is kind of the standard thing, so I don't think I need to explain it in detail. With that out of the way, we can try to implement our solution. So first, we're gonna have a hash map for frequent of character. It basically means how many times a certain character has happened inside S. And also this repeat of frequent is a hash map to tell us how many times for frequent that has appeared. You can assume this is like a frequent of frequent. And for each character in S, then the frequent of character ch plus equals 1. Just fill the first hash map. And then if the length of the unique character is less than k, it means that we can no longer reach the answer. By the way, this length of character will never be larger than 26 because there are only 26 characters if we only consider lowercase. If that is the case, then we can just return 0, and then we're going to iterate every character and get its frequent and fill up our frequent of frequent hash map that we're going to use later. Then we can actually start calculating our answer. Initially, answer equal 1, and then we're going to iterate all frequent, but again, we want to iterate the largest first, so we have to turn the reverse equals true. And for each frequent, we want to know how many times it repeats. If the repeat time is less than or equal to k, it means that we have to pick all repetition of this frequent. So in this case, it's just easy, k minus equal repeat, and then we just need to multiply our answer to frequent to the power of the repeat. As we explained in the solution overview, for each repeat, we have frequent number of choice, and we need to do it repeat time, so it's frequent to the power of repeat possibilities. Otherwise, it means the repeat time is strictly greater than k. It also means that we cannot pick all of the repeat. We have to choose k of them. So in here, we can only choose k of them. So inside the k of them, we have frequent choice, so we can still do frequent to the power of k, but we also have to consider which k to choose from. We have repeat number to choose, and we need to choose k of them, so we need to apply an NCR where n is the repeat and r is k. So with that done, we just directly break, because we know after this k will be exhausted, and finally we can just return the answer. So that's basically all of the solution, and let's try to submit it. Okay, accepted. So for the time complexity is O n log n, where it comes from the sorting, and for space complexity it is O n, where it comes from the frequent of character hash map and the repeat of frequent hash map. So again, I will also link the text version of this solution in the description below, and thank you for watching. I will see you next time. Bye bye.